give to the students a chance to also present. So we are going to start with Amer Ahanovic.
Yes.
So Amer, he is from the University of Sarajevo, and it so happened he was a summer student at CERN working with Maurizio Vretenar and the rest of the group, and now he's in London in Imperial College. Amer, please, if you can finish in 10 minutes, that would be better. Yeah, thank you. So
can you see the slides though?
Very well, we can see full screen and hear you. Thank you.
Okay, cool. Hi everyone, my name is Ahmed, and today I will be giving you a short guide through PhD applications, and hopefully we'll be giving you some of the initial research findings from my PhD, which are regarding the novel patient safety assessment method for higher field MRI. So without much further ado, I'm going to talk about how to start your PhD applications. I will tell you more about what's going on in the primary application and what's happening in the interview process. So where to start, where to look for the funding. There are these 5 main sites that I've summed up here, but I'm going to go over some of them in more detail. The first one is the one that's most important for the UK is the Find a PhD website. It has a very simple outline. You can find your keyword here where you can type down anything really, such as experimental physics or proton therapy, and then you will have some of these projects that will come up. The main thing really here is the focus on is this little sign that indicates the type of funding. So this sign over here indicates there is funding for the EU students, which is great. But if you don't, and if you have your own funding, if you're funded by government, or if you have money that you wish to invest in your PhD, then you can focus on projects that have this little sign over here. But the most important one for the Bosnian students and for most international students is this world sign over here, which indicates that there is enough funding for all your tuition fees and for the living expenses, which is what you're really looking for. You can indicate that you're a non-European student over here, and then that would just list the positions that are relevant for you as well. Another thing that's really important when you select the position, you can see that there's this really simple outline again for that particular position. Here you can see that there's indicated more info and contact. What I would always suggest is that you contact the person early and that you contact them ahead of the deadline. The deadline is indicated here, but also what's important for you is the entry requirements. These usually demand you to have or ask you to have 2.1 honors degree, which is equivalent to 3.3 in the US. But most of them ask you to also have 2.2 degree, which is really not that difficult to obtain. But even if you don't have that, you can contact them and ask if they will accept you with a lower GPA. So don't worry about that. Another very important thing here, of course, is the funding notes. So if they have the international fee band, as I said, then that's really good for you. I would also suggest that to use this button here only because this is a generic button, to email them only if there's no contact indicated on the top of the page. Another one which is really good site, this is good for EU applications. It's very similar, but the main distinction is in this. This is the published date and this is the deadline, but sometimes the deadline is indicating the current date. So if you enter the site today, for instance, some of these positions will have indicating deadline as today, and that is a bug really because the deadline is that position sometimes is ongoing, and if the position is ongoing or if it's all year long, the deadline will be the indicated deadline will be today or the day you enter the site, which is wrong. So always double check. Another one, and the one I found particularly useful, was this one. So this is the year axis. And that means that what I liked about this one, and this is really cool for people that are not the most organized people in the world like me. So this gives you 10 days before the deadline, you get notified by email. And especially if you're applying for a lot of positions, you might find this beneficial. Another one is the Marie Curie Actions. I don't know how much this is active still, but it's always good to explore. For US, there is this PhDportal.com. It's good, but I wouldn't suggest it because it gives an indication of how much the program costs, but it doesn't give you how much you would be paid. But you could easily find here you can easily again find, if you're interested in US, doing PhD in US, you can find the programs that of your interest, but then you will need to go to specific university and find their internal programs. Another thing is the external or other scholarships. I always recommend local government scholarships like the AAD in Germany. So you would, but also the uni-specific scholarships. So you would need to check again every university and every internal university and how that funding, and if they have internal pots of funding that you can apply for. So it really is important that you apply early and that you plan ahead and have some of those in mind. So what is so here you can see what I use. This is really an old-fashioned way of planning ahead, but it worked for me. So if you're a bit old-fashioned, it can work for you as well. But this just means that you need to have a clear plan of what you're doing. This is for a week that I was doing it in, and this was for my exams revision, which is just a stupid example of what I did. But Evernote is really cool application that I'm using in my PhD, and I should have just put it here, but I'm sure you all know about it. Another thing that's really important while applying for the PhD is the inner peace, that to really accept that the fact that you might get it rejected and that a lot of hard work that you're putting in might not really be rewarded. But and you shouldn't really even be thinking about the outcome at the beginning, because it's a long and arduous process, which I sometimes compare to this Poisson log likelihood parametrization, which is just updating algorithm parameters by maximizing the expected data log likelihood. But if we compare ourselves to this little variable theta, if we say that we are all data with our own little luck likelihood functions, then and understand that the life is a process, that life is an iterative process where we're trying to maximize our luck likelihood, then we would always have inner peace with ourselves. We would understand that at a certain point in our lives, we're experiencing just an iterative process, that we're trying to find what's best for us, and eventually we will be able to find it. So now that you know how to start and where to look for it, for the application and funding, let's see what the primary or on-paper application consists of. So the first part is the referees. You should not write your own references. That's one thing that I would like you to focus on. If your supervisor or professor or anyone asks you to write your own reference, that's a red flag and I wouldn't do it. So I would ask 2 or 3 or more professors or others early, and you should mention when and where approximately you would be applying, but you also need to make them understand that there may be more positions you will be applying to. So a draft should be ready before the deadline, of course, and if they're comfortable with that, you should have that draft as well. It should also always include a description of you as an academic personality, of course, your main qualities, but they all know this. But what's really particularly good about references, what they should in fact have, is where, when, and how you specifically have demonstrated your abilities with respect to others, and how you've managed to get extracted from the crowd. So having the references ready, the next thing is the diplomas. The main 2 really diplomas that you need to have is the graduation diploma and intern grades transcript diploma. If you can't have graduation diploma ready, or if your program is ongoing, you just collect a certificate from your university or from your students affairs that's confirming that your current program is ongoing and that you need to, and that based on your current academic performances, you are expected to graduate at the indicated time. Additional diplomas are always beneficial, and you need to collate them in a certain way that makes sense, of course, but also make sure that all of them are in English. And if they are not in English, you need to translate them via court interpreters. Another thing is the Toefl or Ielts, and this is really important because most of the international programs demand you to have Toefls or Ielts. And you should register for these early, way before the deadline of the application. But if a deadline is approaching and you don't have a Toefl, please don't panic, because you can ask, and sometimes the programs don't even demand you to take Toefl, or they can give you extra time to do the Toefl or whatever. But some programs may just accept the official university confirmation letter stating that the program language of instruction is English, if your program of instruction is in English. So keep that in mind. For USA, usually they ask for GRE general tests and GRE subject tests in addition to this. And this is definitely the case for the physics programs. Another thing you need to have is the CV. You should use a minimalistic and specific approach, especially if you're a student. You're not expected to have many things done, but whatever you have, make sure that you would be able to explain that later on if you're asked about it in an interview. For the motivational letter, I always follow this rule, and it's helped me a lot. So it should answer the following 3 questions. Why the chosen areas? How is that relevant for your further career plans? Why this program that you've chosen at this university with this specific supervisor on this project? It needs to be specific. And then the final thing that needs to say is why you. Why should they select you? What are your qualities and what you can contribute to this program and what you can learn really from the program. So also make them see that from the writing that you're enthusiastic, eager to learn and determined, but also be very specific with clear examples. And this is really what I did. I literally just answered those 3 questions in my application form for the London CBT program. Regarding the timeline, so these are the 8 things that I would do before. So you do your English tests, you search the sites, plan, contact the people relevant for the position. Then you select the positions you wish to apply for, contact your referees, collect the diplomas, make the CV and motivation letter, and then you apply. This process is really arduous until the point 8 here. But then after that, it's just, again, iterative process. You apply, you modify it, you apply, but you always need to modify. I wouldn't send the same application. I wouldn't send the same motivation letter to any of the positions I applied. I always modified the motivation letter and or CV. Sometimes CV stayed the same, sometimes it didn't. But you mainly modify your motivation letter. That needs to change. But it's really easy. And the more you do it, the better you get. And that's how you sort of approach the maximum of your luck likelihood. So now that you know what the primary application consists of, I'm going to give you a bit more details about the interview process. So before, again, I would send
Amer, what people can read, maybe you can skip fast and wrap up in a couple of minutes.
Okay, I'm going to wrap up. Okay, so you can send always emails of inquiry and contact the potential supervisors. And this is what I did as well. And this is something I didn't know really when I was applying for the position. I sent after they've invited me for the interview, I sent just an email asking about the interview. And as a matter of fact, the professor sent me these 2 questions that he would ask in an interview that nobody really had known. And he was doing this to the people who had asked emails. So what professors usually want students to do is to show initiative. So if you send them emails, they're more certainly to help you. Of course, then you need to train hard for the interviews. You should plan with someone and train and try and hard. Again, be ready to discuss your CV and motivation letter in your interview process for the technical part. The 5 magic terms that you are also using to assess the group, but you can also use to tell them that you are interested in seeing is the interdisciplinarity of the research, which is really important today. The group activity, how much research output they have, if they're collegial, how you're assessing their collegiality as well. If they have a good student-professor interaction, if they're eager, they also need to be eager to learn and study. You also need to be eager to learn, and that's what academia is all about. You can always, in the interview, we will probably be asked simple questions from the field, but also from your CV, the projects you did, and you can get asked for discussions on scientific paper and your future tasks. But regarding just a couple of instructions regarding the presentations, 1 slide should be equal to 1 minute, which I clearly haven't done here, but you can take this presentation and hopefully use it for later. But use a lot of visuals. Don't follow. This is the presentations that the presentations follow also the scientific methodology, or this outline, but don't name the titles of your slides as that. Don't underestimate your audience, so don't focus on the trivial matters, but do not overestimate them either. So avoid using jargon, abbreviations, or the stuff like that. And you should always ask yourself what your audience needs to gain from this or learn from this. How is this beneficial for them? And you need to sell yourselves. You should always remember that you need to sell yourselves in the interviews. Okay, this is something that summarizes that. And also another thing that with regard to the audience attention, if it's long presentation, you always need to have intermediate conclusions, which will keep your audience's attention better. Okay, you can always ask questions back, and you should you should do that. That's encouraging. And I'm gonna skip that because you know that. But regarding the during part, you should be confident. You should maximize signal to noise ratio. I had a fail with an interview in Liverpool. They couldn't hear me. I couldn't hear them, and it was all a mess. But luckily, the rest went well. You should make sure that the audience understands you well, that you can keep their focus. You should also encourage negative feedback. You should say things like, what would, if you're presenting your project, you should ask them what would they do differently and how would they, if they've done something like that, you should just ask them if that method could be applicable to your research and stuff like that. And always be courteous and respectful of their negativity or criticality or whatever. If they're, whatever the outcome of the interview, you should respond in the next 24 hours saying thank you, and then reject the positions you don't want to go with and just accept the ones you would like to go with. Okay, and with that, I would like to finish this presentation. I haven't had time to tell you much about my research, but hopefully some next time we will, and I hope this was beneficial to some of you.
Thanks very much. Certainly it was interesting for all the students, and encourage you to continue with the social events in the chat so that you can tell them more details. If I can ask you to please unshare so we can go to the next speaker, that is Fehima Ugarak from the University of Sarajevo. Can you unshare, Amer? We still see your presentation.
Okay, sorry.
And Marius already anticipated in the morning her presentation that will be in IBA applications.
So hello everyone, my name is Fehima Ugarak, and today I will speak about ion beam analysis applications. So today I will tell you why am I speaking about this topic. Also, I will guide steps during my investigations, and at the end, I will present results and a conclusion. So this morning, Marius Sapinski was giving the presentation about this project. So the main goal of this project is to build a simple low energy accelerator setup at the University of Sarajevo. And that setup would be useful for research, education, and potentially for study of medical radioisotope productions. And the project, it has two phases. Phase one is for low energies and the phase two for high energies. My part was to find what are the potential applications of this laboratory. And also here I needed to find which methods would be useful for our scientists here. And at the beginning, we didn't know which ion source can be used. And so we had a lot of meetings with different companies. And at the end, we decided to use nanogun source. And this nanogun source can provide these kinds of ions, currents, and types of states. And also at the beginning, we didn't know which ion source. And my part was to investigate ion sources that are used, ions, their currents, and energies. So I will be focused on that part. About ion beam analysis applications, you heard this morning from Milko Jakšić, and this is a figure that is presenting that a lot of these applications are using high energy ions. So only this one, the first one, secondary ion mass spectrometry, is using low energy ions. So only that one would be useful for our phase one. And this method is using cesium ions, oxygen, argon, or oxygen, argon, cesium, or gallium ions that are implanted inside of the sample. And those atoms can be in depths of to 1 to 10 nanometers. And this is used in materials to getting information about elemental distribution of the elements, and also it is used for solid state materials like insulators, semiconductors, metals, and etc. And this figure here 4 is presenting just basic setup. So I have a lot of methods, so I will not focus on this slide. And the second one is low energy ion scattering method. This method is used in analysis of thin film growth and also in chemistry. And it is using noble gas ions like helium, neon, argon, and krypton ions with those low energies. And here are currents in order of nanoamps. And also figure 6 is presenting basic setup for this method. The next one is ion implantation. Here I used mostly helium ions to implant in different magnetizable thin film. And this is used for making changes, and that's making changes in their electrical and optical and chemical composition. And this is useful in industry for making nanotubes, what is used later for making microchips, and afterwards to get different kinds of sensors. The next low energy application is in stellar physics. So those kinds of laboratories, they are doing those nuclear fusion reactions with proton beams and helium beams. And the main thing that those laboratories are, they are mostly made underground. This LUNA stays for laboratory for underground nuclear astrophysics. And here are just these extractions that are investigated and the main components. Next application is in biology. So this application is wider than just in biology. And here are used nitrogen ions for making mutations on seeds. And those seeds are afterwards, they are grown, and we can see differences between those stems here, color and shape. And also this is used in microbiology and etc. And next application is on graphene nanomaterials. So here I use different kinds of ions for making defects inside of those materials. And this application is one application that is asked from the university, because there is one young professor who is doing this research, and he's mostly interested in this one. And the phase two, when we have RFQ, we heard this morning presentation from Marius that is connected with those phases, phase one and phase two, what is. And phase two means that we have high energies and the application is wider. And the one that I like the most is PIXI, particle-induced X-ray emission. This figure was mentioned this morning on the Milko Yakshi slide, and I took it also from his presentation that he sent me before. So PIXI method is using mostly proton beam and helium beams to ionize atoms, and we get emission of X-ray. And this X-ray is identity card of the atom that is inside of the sample. And we can analyze those X-rays with different detectors. And figure 13 presenting components for this method. And also here I mentioned energies. Van de Graaff accelerator is one that is mostly used, but there are studies about using RFQ also. And currents that are needed for PIXI are in order of nanoamps, because larger than those here, they would create pileup effect. And pileup effect is overlapping of peaks in spectrum, so we wouldn't be able to read which element is detected. And here I put just some applications of this method, and there is more you can read later if you want. I just want to mention this one and the second one. This one is prosthesis degradation. So here is analyzed blood of the human to get information about concentrations of metal particles that are inside of human blood as a result of this prosthesis degradation. And next application is for analyzing of air and water samples and food samples, because I did something similar for my bachelor thesis. I was measuring radiation in those kinds of samples. And that is the main reason why I was the most interested in this one. And the second one is RBS. So this method we choose because this method is one that can be combined with PIXI because it is using the same electronics. And RBS is used for atoms that have atomic number less than natrium, and PIXI for higher ones. and RBS is more for solid state materials. And here I just put applications in metallurgy, solid state physics, electrochemistry, and surface science. And here is this setup that was shown. This setup is one that we, after our discussion, realized that can be feasible. And I take measurement of this room, and my sister, she helped in doing this sketch in AutoCAD. She's a civil engineering studying. And as a summary, I would like to here present what we realized about those methods. And this table is presenting our conclusion for just for low energy applications, which are feasible and which are not. And SIMS and LACE, they are not feasible because this one part of the equipment, electrostatic analyzer, is one that is most expensive. And nanogun source can be used for those two methods, but the problem is that with nanogun source, we can get higher currents, and those methods are using less current. So it's not that smart to buy more expensive ion source to get lower currents. Then we need much more equipment to decrease the current. And ion implantation, this is a feasible application, but we didn't find interest still. For graphene nanomaterials, this application, I already said that the chemistry department is asked for. Stellar physics is put like rather not, because those laboratories, as I said, are mostly made underground, and we need additional shieldings. And okay, and the last one, biology, agriculture, microbiology, and medical application. We need also interest from our scientists. And thank you.
Great. Thank you very much for this nice presentation, Fehima. If I can ask you to please stop sharing.
Okay.
Unfortunately, training the students to perform under stress. And now we have the next presentation by Aris Mamaras, my right hand in organizing this school. Giovanni also anticipated his presentation on linear accelerators for radioisotope production. Aris, please,
yes,
you can go ahead.
You can see my slides, right? Yep. Okay, thank you, Jota, for the introduction. Hello, everyone. I'm Aristides Mamaras. I'm a master's student in computational physics at Aristotle University of Thessaloniki and currently a technical student at CERN. Before I start my presentation, I would like to say a deep thank you to Jota Foka, because without her, this school at this level wouldn't be feasible. And of course, Nicholas Samud for his valuable help. And additionally, I would like to thank the heroes behind the scenes, which are actually the small team that we have created, consisting of Rebecca, Damir, Amar, and I, who helped in preparation, organization, and moderation of this school. So now I'm continuing with my presentation, which is focused on the radioisotope production using linear accelerators. Actually, this subject started along the lines of the bachelor thesis at Aristotle University, where I had to investigate the possibility to use linear accelerators for production of radioisotopes commonly used for PET imaging. An example of that one, the most well-known actually, is fluoride 18, as you can see on the right-hand side, which is produced by an accelerating system and then labeled to the molecule of glucose, creating in that way, through a chemical process, the fluorodeoxyglucose. So in general, radioisotopes are usually produced by cyclotrons in dedicated facilities and then transported to the hospital for their use. So the basic idea was to install a Linux-based system for radioisotope production near or ideally at the location where the radios are going to be used, since Linux may offer many advantages compared to the cyclotrons. As we have heard before, during the whole week of the school, the main component of the linear accelerator is the radio frequency quadruple. So combining several of these modules, we can reach higher energies. Two possible Linux designs can be seen in this slide. You can see on the first one, on the left-hand side, we're combining two RFQs together with some RF amplifiers. And this Linux system can reach energies up to 10 megaelectronvolt for a beam current of 20 microamperes and a duty cycle of 10%, reaching a length of 4 meters. While another possible design can be seen on the right-hand side, where we have more RFQs this time, smaller ones, reaching energies of 6.5 MeV with a beam current of 30 microamperes, a duty cycle of 4%, and a length of 2.5 meters. So the question still remains if such a Linux-based system can produce sufficient yields for supplying a medium-sized hospital, and at the same time also be used for injecting to synchrotron at the same energy range. So in order to answer to this question, we calculated the production yield of fluoride 18 for PET imaging, as I mentioned previously, together with the corresponding number of PET doses. So with the help of my professor from Aristotle University, Mr. Lelios Anastasios, and of course with the help of Jota Foka and in close collaboration with Dr. Maurizio Vretenar here at CERN, we developed a method of numerical calculations for radioisotope production to search for an energy range in which we can achieve efficient radioisotope production while keeping the same time the setup compact and cost effective, and also investigating the possibility for injection to the synchron on the same energy range. So here you can see the relation that gives the yield of a radioisotope. So we can see that it's strictly related to the beam current and also a quotient of the cross-section as a function of energy, which is also well known through the graph form with the term of excitation function. You can see below an example of this graph to the stopping power of the target material. Additionally, in this exponential term, when we have for a longer time of irradiation, of the target irradiation, the production rate reaches, it's equal to the decay rate. So it reaches equilibrium, and it's well known for as a saturation factor. So for practical reasons, a saturation factor is considered to be 3.5 half-life times of the radioisotope. So in this slide, I have the numerical method we calculated and developed. So to begin with, one should know the type of the particle beam, and also should know the range, or in other words, the maximum depth that this particle beam can reach inside the target. So this can be found through the literature. So by knowing that, we can then separate the target in several thin slices of equal thickness delta X. So by knowing the initial kinetic energy that impinges on the slice, then we can get from the literature the corresponding value of the stopping power, which is valid in the whole slice and constant for small variations of energy. And then we can calculate the energy loss inside this slice by the product of stopping power to the slice's thickness. And subtracting this amount from the initial energy, we can calculate the remaining energy, which will be also the initial energy for the next slice. So proceeding in the same way, we can find in the following slices, we observe an energy deposition until it reaches zero, which in our image here can be seen somewhere around the 8th slice. Regarding, however, the calculate of the yield in each slice, we will need an additional amount of factors, such as the cross-section as a function of energy, the number of nuclei of the surface density for each slice, the particle flux, and the radiation time and the decay constant of the radioisotope that we want to produce. So at the end, we find the yield as the sum of the yields in each slice. Having said that, we implemented our calculations for producing, for calculating the yield of fluoride 18 from a proton beam impinging on an enriched water target. You can see here in this graph on the right-hand side the results and also the corresponding PET doses. And at this moment, I will need also to say that during my internship at a hospital in the northern part of Greece, in Thessaloniki, I discovered that after they were supplied with the PET imaging radioisotopes from Athens, which is the capital of Greece, 6 hours away from Thessaloniki, which the facility there produced 120 gigabecquerel of isotopes, from which only 15 reached the hospital and only 4.5 gigabecquerel were actually used. So we can understand the amount of yield that was being lost. So to take a step further, we wanted also to investigate if these possible two Linux designs could produce sufficient amounts of radioisotopes. So we implemented the calculations, and we found out that at saturation times for the first design on the left-hand side, we resulted to 104 gigabecquerel, which corresponds to 282 PET doses. And for the design on the right-hand side, for an amount of 74 gigabecquerel were produced, which corresponds to 200 bed doses. So it's a sufficient enough amounts for supplying a medium-sized hospital. Now, in the context of the CEAST project, a cancer therapy facility is being designed, and you can see here the 2D drawing designed by Dimitris Kaprianis, the Greek architect. So you can see here the different areas where different elements can be situated, such as the treatment rooms of the patients and also the synchrotron. And you can see on the right-hand side below, in a red oval scheme, the place where the LINAC should be situated, and you can see at the end resulting in two different lines, one for supplying the synchrotron and the other one for use that will going to be used for radioisotope production. And also there is a possibility for an extension to construct a unit dedicated to the extraction of the produced radioisotope from the target and the production of radiopharmaceuticals, as also Dr. Mauricio mentioned before. And in this way, this LINAC system will provide enough amounts of radioisotopes for the facility, and also the surplus could be used and made available to other hospitals, working at the same time as an external income source for the facility to balance the costs. And also open up a research field for exploring more promising radioisotopes for diagnosing and therapeutic purposes. So ending my presentation, I would like to conclude and look to the future prospects. So while I'm here at CERN, I'm investigating for new radioisotopes used for theranostics, since using LINAC for their production is very optimum and promising. Also, we study the simultaneous optimization of the parameters needed for this LINAC system. And we will also going to optimize the design of this area, including efficient the protection methods, shielding calculations, and appropriate construction materials. Thank you very much.
Thanks very much, Iris, for this interesting presentation and keeping on time. And we will come now to the next presentation. That is something different by Ivan Kotlaya. If you would start sharing your screen, Ivan. Yes. He will discuss federated learning system application in heterogeneous healthcare data sets. Ivan is selected as a CERN summer student and will start working with his supervisor, who is called also Ivan, on this topic at summer. He is funded by our sponsor, Eddie Offerman also. Please, Ivan, go ahead.
Thank you, Ielts. Hello, everyone. Glad to be here. I won't take much of your time. As my project has not yet begun, I've been instructed to say a few things about myself. So I'm Ivan Kotlaya from Montenegro. You've met a couple of people from here already, like Maya and Amar. So I've done my bachelor's at the Mediterranean University, where I'm a teaching assistant, and I'm working on my specialist degree and doing the master's program at the Malerdalen University, which is an exchange program sponsored by Erasmus, doing work involving safety critical systems, but a lot of work was intended to be in collaboration with bombardiers, so it was difficult to coordinate due to COVID. There I studied real-time systems, which is what MDH is known, published research-wise. And most importantly for this project, I refreshed my understanding of learning systems and became familiar with research methods. Lastly, I'm working as a backend developer where, among other things, I work with distributed systems, databases, and event streaming. So there's always some interesting issues to tackle, which might prove useful for this federated learning project. Now, a brief summary of the plans for the project. I've been assigned to work with Ivan Knežević, who is, as Ielts mentioned, also from Montenegro. So standard machine learning procedures require centralizing the training data on one machine or in a data center. So here we have a model which is trained on the machine with the data, and we get a new improved model. But if we try to add more data from different sources due to the nature of the data sets we work with, we run into issues like protections because of HIPAA or GDPR or other various issues. So there are already methods used to increase privacy when gathering or using data, like differential privacy and the secure multi-party computation. So for differential privacy, in summary, one of the ways is basically adding noise to data while gathering it, so we cannot identify an individual response in the data set. And for secure multi-party computation, we basically train the model on encrypted data. So these are not exclusive, and we may end up combining these with federated learning, which was pioneered at Google a few years ago for Gboard, so their Android keyboard autocorrect improvements. So basically, they set it up so the phones train the model locally based on the user's usage, and all of these model updates are aggregated to form as a consensus change on the shared model. So after which the procedure is repeated continuously to improve the model further. So by doing something similar in combination with some of the mentioned or not mentioned methods, the plan is to do this in phases where firstly, kind of ironically, we would like to get some actual data in order to see what we can do with it and how to alter it so we can combine it with data sets from different institutions, basically solve the heterogeneous part of the title. We get different types of data like text, structured or unstructured, and different types of images, all of which will impact our decisions. It's important to mention that despite only sharing the model between us and the institutions, not the actual data, it's still not secure, as work has already been done to show that models can memorize some very specific data, which can end up containing enough information about a particular individual to make them identifiable. So that has to be taken into consideration. Personally, before I started looking into this, I figured we could just redact some data here and there, mask some other data, and be done with it. However, while watching an MIT series about preserving privacy in deep learning, I learned that Netflix had launched a competition offering a prize of $1 million, where they released an anonymized data set of ratings where movies and users are replaced with numbers. It literally looked like this. This is straight from the data set. So basically, some researchers at the University of Texas, Austin scraped IMDb and managed to find enough matches and patterns that they could de-anonymize a lot of these users, despite initially only having this as the data set. So again, privacy should really be a priority, so this data cannot be abused if leaked in some way. There's a lot of tooling out there to help us at the moment, like TensorFlow Federated, PySift, PyGrid, Model Optimization Toolkit, etc. So we'll probably end up using some of that, but it's still early to say, so I didn't include it in the presentation. That's it for now, and thank you.
Thank you very much. That's very interesting, and we wish you good luck with your project and that you enjoy it. If we could ask you to please... Yes, perfect. So unfortunately, we will have to skip the discussion and preparation for the quiz questions that Damir is going to contact you offline and get your suggestions. And I would like to use some 5 minutes. We have with us Egypt, the University of Benha, and Mahmoud, you are there. Okay. Since this school is about treatment planning, we are going to see a couple of results of the students working in Egypt on the homework that was given yesterday. 5 minutes, Mahmoud, yes? Thank you.
Okay. Firstly, I'd like to introduce myself. I'm Abdullah, a student in Biotechnology Department. In this presentation, I'd like to show an Alderson case. It wouldn't exist in your tasks, by the way. So we take this challenge and we try to set those plan for this case, which will present by Egyptian students. I would like to add this. I would like to add that this simulation is wrong, but we exert an effort to make it true. Here we use one angle beam photons as you show in the screen. It's totally wrong, but it was the first try to make it true. And my next colleague will represent the next slide.
Hi, I'm Habiba, Faculty of Science. We effect on this case, we're using proton radiation with two angles. CTV value is 3.336 and the value of PTV is 3.284. We notice that CTV value is take radiation more than BTV according to the results from the graph, but badly two radiation are very high. So with another simulation to get the main target. I will leave the next slide to my friend Rana Hashim. Hello, I am Rana Hashim. In the simulation, we use triangle beam with proton radiation. We notice that the CTV has the height value of 3.3366 and BTV with the value of 3.2818, which is required, but we did another simulation so we can get better result. But my colleague will explain this one.
Hello, I am Mahmoud Muhammad. In this simulation, we use two-angle beam of photon, as we see here. Um, with other tissue, with tumor had some side effect. In this table, we notice that the main values of all tissues had affected by a quite high effect. As we see here, the CTV value equal 1.9982 and the BTV value equal 1.9958. For the next simulation, my colleague will explain.
Hello, I'm Gina Thabit. In this simulation, we used radiation of photon. With 5-angle beam, we get a result that CTV take a higher radiation, but also BTV take a high radiation, and we wanted the healthy tissue not to be damaged. So we did another simulation that my next colleague will explain.
Hello, I am Iman, Faculty of Science. I come with better result in this slide as CTV takes radiation more than BTV. So we tried more and more to get the most perfect target with my next friend.
Hello, my name is Mariam, and my slide is the next trial of my friend's outcomes, and we have here more scattered in radiation, but it is less energy and less harmful because the isocenter takes the most of the energy of the radiation. Um, and we see the mean value of the ratio between CTV and BTV is 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 acceptable for the tissue. However, of the scattering of radiation, but the most of the energy of radiation are concentrated in the CTV center. And now we are moved to our next trial with my friend.
Hi, my name is Muhammad Sabri. In this attempt, I used Pixel 8 carbon radiation mode and the auto isocenter settings. And the type of optimization I used LimeFarB, and this was after that I tried to save the red eye from sedation effect, but I found that I'm gonna damage the spinal cord, so I choose to risk one of the two eyes instead of the spinal cord.
Hello, my name is Tasneem. I will talk to you about the summary to compare between the final results for treatment of Alderson. We will just try to get a perfect result. In this table, we just arrangement the results from the worst result to the perfect result, but unfortunately, we don't achieve the main target by high radiation as CTV take maybe low radiation and BTV take high radiation. So we will try again and again, and we just do a try as scientists do. But This case, unfortunately, have hypoxia, so the radiation can't identify GTV and try the radiation concentrate on CTV only, but it is a bad result. So we can do another simulation to get a perfect result from, as we see from these numbers. By this way, we learn from all scientists to try and try a lot to get the more perfect result. Thank you for attention and goodbye.
Okay, thank you, Yuta, and
Perfect.
all to listen to my.
Great, just on time. And now I think we can go back to the plenary session. And we have, I can ask you to unshare, Mahmoud. Yes, then before closing, we would like to remind you about the evaluation form. Many you have already submitted the evaluation form for the school, but now we have an evaluation form for the social events that Rebecca and her team have prepared with so much care. And we would like you to take some time to fill it and give your feedback. Okay, just that you have an idea of the social events. There are a few questions there. Actually, every day had a theme. We were even supposed to have an outfit every evening, but unfortunately, my fault, there was never time to have a break between the lectures and the social events. But still, I think people that joined enjoyed it. So, okay, I think with that, we are coming to the